This is my sixth video lesson for Unit 13. In this lesson, we will discuss neutralization, motivation. Given this chemical reaction, what type of reaction is this? Based on what you learned last term, this is a double replacement reaction, but since the products are salt and water, this is a special type of double replacement reaction. This is a neutralization reaction as well. Learning target. At the end of the lesson, I will be able to analyze a neutralization reaction. Homework will be number 6, which will be a Junipod based off this lesson. Neutralization is a special type of a double replacement reaction. Neutralization occurs when equal moles of acids and bases react to produce salt and water. This is based off Arrhenius theory. For non-Arrhenius acids and base reaction, they do not produce water. The hydrogen ion is just transferred. Here is an equation and example of a neutralization reaction. The red represents the acid, the blue represents the base, purple represents the salt. Salt is an ionic compound that is produced in an acid-base reaction, not necessarily NaCl. Learning check number 1, which equation represents a neutralization reaction? Pause the video and resume as completed. The answer is choice 1. Here is a base reacting with acid to produce salt and water. Learning check number 2, what are the products of a reaction between KOH and HCl? Pause the video and resume as completed. KOH is the base, HCl is an acid. So this is a neutralization reaction. So the product will be salt and water. So the answer is choice 2. Learning check number 3, which reactants form the salt calcium sulfate in the neutralization reaction? Pause the video and resume as completed. You're looking for one reactant with calcium and the other reactant with sulfate. So the best answer is choice 3. H2SO4 is sulfuric acid and calcium hydroxide is a base. Learning check number 4, as the barium hydroxide solution is added to a solution of sulfuric acid, the electroconductivity of the acid solution decreases because the what? Pause the video and resume is completed. Acids are electrolyte. As you can see in this neutralization reaction, barium sulfate is formed. If you check table F, barium sulfate is insoluble in water. Therefore, electroconductivity will decrease because the concentration of ions decrease. So the answer is choice 4. Now we're going to discuss the pH of the products of the neutralization reaction. There are 4 scenarios. On the regions, they just ask 1, which is a strong acid plus strong base scenario. When a strong acid reacts with a strong base, the pH of the products will be 7. This is because when equal moles of strong acid and strong base reacts, they form neutral salt and water. Here is an example of a strong acid reacting with a strong base to form NaCl and water. NaCl and water are considered neutral substances and have a pH of 7. The second scenario is a strong acid and a weak base. The pH of the products will be less than 7. So why is that? You're still having equal moles of acids and bases, but the product is an acidic salt. So here we have HCl, which is a strong acid, and NH3, which is a weak base. When they react, they form ammonium chloride. Ammonium chloride dissociates in water and is considered acidic salt. The reason why it's considered acidic because when ammonium interacts with water, it forms hydronium ions. Hydronium ions will lower the pH. The third scenario is the weak acid and strong base. So the pH will be greater than 7. So why is that? Even though there's equal moles of acids and bases, you're forming a basic salt. So here we have a weak acid, this is acidic acid, reacting with a strong base, sodium hydroxide, you're forming NaAC and H2O. This is a basic salt because when it interacts with water, it forms hydroxide ions, which raises the pH. The last scenario is a weak acid and weak base, so the pH can vary close to 7. Even though it's equal moles of acids and bases, it typically forms a neutral salt, but it depends on the reactant's identity. Just a reminder, only the strong acid and strong base scenario will be on the Regents exam. Learning check number 5. What is the pH of a solution that results from a complete neutralization of HCl solution with KOH solution? Pause the video and resume as completed. HCl is a strong acid and KOH is a strong base, so the resulting pH will be 7. Choice 2. For practice number 2, here are some examples of reagent sphere response questions. You're given an acid and a base. Complete the following neutralization reactions. Predict the products. I would do the first 2 questions as an example. For question A, we have hydrobromic acid reacting with sodium hydroxide. What are the products? Since it's an acid-base reaction, one of the products has to be water. To get the salt, we have to switch the ions and use the crisscross method. So let's first figure out the charge of each of the ions. Hydrogen is positive 1, bromine is negative 1, sodium is positive 1, and hydroxide is negative 1. So the hydrogen ion and the sodium ion will switch places. So the hydrogen ion is going to combine with hydroxide to get H2O, and sodium will combine with bromine to get the salt. Using the crisscross method, the chemical formula of the salt is NaBr. Let's look at question B. We have potassium hydroxide, which is a base, reacting with hydrofluoric acid. Since this is an acid-base neutralization reaction, we know the products will be water and a salt. To get the salt, we have to switch the ions. Potassium has a positive 1 charge, hydroxide is negative 1, hydrogen is positive 1, and fluoride is negative 1. So we're going to switch the potassium ion with the hydrogen ion. The hydrogen ion will combine with hydroxide ion to get H2O. The potassium ion will combine with fluoride ion to get the salt. Crisscross the charges to get the chemical formula. The chemical formula of the salt will be Kf. Try to do the rest of the questions by yourself. Pause the video, resume once completed. Here are the answers. For part 2, you're given salt and water, which is the products of a neutralization reaction. Predict the reactants, which are the acid and the base. To get the acid and the base, you have to work backwards. In question 1, you're given potassium iodide, which is the salt, and water. The first step is to identify the charge of each of the ions. K is positive 1, I is negative 1, water is H+, and hydroxide. So next you switch the charge backwards. K is going to switch with H. By doing that, you'll get KOH plus HI. KOH is the base, and HI is the acid. For question 2, we're first going to identify the charge. Sodium is positive 1, nitrate is negative 1, water is H+, and hydroxide. The sodium is going to switch with H. By doing that, you'll get NaOH, which is the base, and HNO3, which is nitric acid. Try to do the rest of the questions by yourself. Pause the video, resume as completed. Here are the answers. Describe what is happening. Here we have a molecule reacting with water. Water is splitting this molecule into 2 pieces. This is known as hydrolysis. In the context of acids and base chemistry, hydrolysis is also defined as a salt reacts with water to produce an acid and a base. This is the opposite of neutralization. Let's look at an example. NH4Cl is a salt and is reacting with water. In a hydrolysis reaction, water is used to split a molecule into 2 pieces, as you can see here. So the products of this reaction is NH3 and hydronium. Hydronium is an acid. Is the resulting solution acidic or basic? It is considered acidic because the solution has hydronium. Check of understanding number 1. Which of the 4 scenarios where acid-base hydrolysis occur? How do you know? Let's analyze neutral salts. Neutral salts are formed from strong acids and strong base neutralization reactions. As you can see in this equation, NaCl does not react with water, it just dissolves in water, which is a physical change. So no hydrolysis. For acidic salts, it's formed from strong acids and weak bases. The acidic salt reacts with water to form hydronium. That's why the salt is acidic. Hydrolysis occurs in this chemical reaction. For basic salts, is formed from weak acids and strong bases. The basic salt reacts with water to form hydroxide. Learning check number 6. Which compound is a salt? Pause the video, resume as completed. A salt is an ionic compound that is a product of an acid-base reaction. So the answer is choice 1, lithium nitrate. H2SO4 and HF are acids. Sodium hydroxide is a base. Here's a summary slide summarizing what we discussed in today's lesson. This concludes the video lesson. Remember to do the Junipod homework.